Have you ever considered that nitrogen could be a ticking time bomb for our environment? Right now, a silent crisis is unfolding, driven by a tiny enzyme called urease, and most people are completely unaware of the risks it poses. Nitrogen cycling might seem like a dry scientific topic, but it's a matter of urgency. Small miscalculations can lead to catastrophic consequences: polluted water supplies, failing crops, and collapsing ecosystems. This isn't just hypothetical, it's already happening. Urease plays a crucial role in converting urea into ammonia, which is essential for plant growth. However, when artificial intelligence misjudges urease activity, it disrupts the entire nitrogen cycle. Imagine it being a farmer who relies on A for soil health. You trust the technology, but what if it miscalculates urease levels? Your crops could suffer, yields could plummet, and financial ruin could be just around the corner. This is the harsh reality many farmers are facing, and it's more alarming than you think. The real threat lies in what goes unnoticed. The effects may not be immediate, but the long-term consequences can be dire: waterways turning toxic and ecosystems collapsing, all due to a simple mistake in urease calculations. It's shocking how easily this can slip under the radar. You might be asking, what can I do? Awareness is your first line of defense. Understanding nitrogen cycling is crucial. It's not just about knowing the facts, it's about recognizing the urease warning signs before disaster strikes. Picture yourself in a field, proud of your lush crops, yet sensing something is off. That's the danger of ignorance. You need to stay informed and question the algorithms that dictate your farming practices. So, what's the takeaway? When you hear about A in agriculture, remember urease. It's not just a technical term, it's a potential crisis looming on the horizon. Educate yourself and others. It's time to shine a light on the hidden dangers of error-related urease miscalculations in nitrogen cycling. Before you leave, consider your role in this fragile ecosystem. What actions will you take to safeguard our future? Stay curious and informed. The health of our environment depends on it. Did you know there's a hidden threat right beneath our feet? You might not realize it, but this could completely change how you view nitrogen cycling. Picture yourself walking through a lush field, surrounded by vibrant crops. What if I told you that something as ordinary as urease could jeopardize this entire ecosystem? Many people are blissfully unaware of the risks posed by induced urease miscalculations. You might think this issue only concerns scientists in lab coats, but it affects farmers, gardeners, and even the air we breathe. Miscalculating urease levels can trigger a chain reaction of unexpected consequences that impact our environment. Consider this: a farmer uses A technology to optimize fertilizer application. He trusts the algorithms, but those miscalculations lead to an oversaturation of nitrogen. The crops begin to suffer, soil quality declines, and the entire ecosystem gets thrown off balance. So, why does this happen? AI systems analyze vast amounts of data, but they are not infallible. They can overlook subtle signals, those urease stress signals that indicate something's amiss. The data might look good on paper, but the reality is often more complex. You might think, that's just a tech issue. But what about your own backyard garden? If AI tools aren't calibrated to catch these nuances, your petunias could be struggling without you even knowing. It's a silent disaster waiting to unfold. Let's raise the stakes. Overfertilization can lead to nutrient runoff, creating dead zones in our water bodies. You might enjoy a summer swim, but what if those waters become overwhelmed by algae blooms fueled by miscalculated nitrogen levels? Now, let's get to the heart of the matter. What can we do about it? It starts with recognizing that the tools we rely on aren't perfect. Just as you would blindly trust a map missing key landmarks, you shouldn't overlook the limitations of AI in managing our ecosystems. The solution is to take a more hands-on approach. By collaborating with technology instead of relying on it entirely, we can blend human intuition with AI insights. This creates a safety net ensuring those Urease stress signals are detected and addressed before it's too late. As you reflect on this, ask yourself, are you truly seeing the full picture? The next time you stroll through a garden or a field, remember that beneath the surface, a complex battle is unfolding. Don't let your awareness stop at the surface level. Stay curious, stay alert, and always dig a little deeper. If you want to keep up with these important discussions, subscribe for more insights that matter. Your awareness could make all the difference. Did you know that even a small miscalculation in nitrogen cycling can lead to significant agricultural failures? It might sound dramatic, but it all comes down to something we often overlook: urease. This frequently ignored enzyme could be a hidden troublemaker in farming. Many don't realize how a tiny imbalance can trigger a chain reaction of problems. Imagine a crop's wilting under the sun, soil losing its vitality, and farmers left scratching their heads, wondering what went wrong. Urease plays a crucial role in breaking down urea into ammonia, which is essential for making nutrients available. However, AI tools designed to optimize this process often make assumptions that could cost millions. Picture relying on software to determine your fertilizer needs, only to discover it miscalculated the urease activity. Think about the implications. A farmer following an AI tool's recommendation for a higher nitrogen application based on faulty data may face ammonia volatilization and soil acidification instead of flourishing fields. This isn't just a minor setback, it could lead to financial disaster, food shortages, and a ripple effect impacting entire communities. Beneath this technical jargon lays a bigger issue: the disconnect between technology and real-world outcomes. How many people are blindly trusting algorithms without understanding the science behind them? A misplaced trust in AI could lead to serious consequences, yet many remain completely unaware. Let's explore this further. Imagine walking through a vibrant field, only to return days later to find it barren. This isn't just a hypothetical scenario, it happens. A farmer's reliance on predictive analytics might blind them to the realities of urease dynamics. The failure